So if you start up a car engine, you're going to get you're going to have chemical energy before you start it up. The chemical energy is stored in the fuel and in the air around it, and then when you burn that fuel air mixture, you transform that chemical energy into kinetic energy. That's what the kinetic energy is, what moves the piston, and ultimately gets transferred to move the car. You have sound, right? There's no gas powered car that is perfectly silent. So that's non-mechanical energy. That's sound. And then we have or non-useful mechanical energy. And then we have the heat. So the heat is an increase in internal energy of the rest of the car, and that's also non-mechanical energy. And we don't want that non-mechanical energy. The desired outcome of the energy transfer within the engine is that we want as much chemical energy as possible to be transformed into mechanical energy, or more specifically, kinetic energy. We want that chemical energy to be transformed into kinetic energy. Every other kind of energy that is made is waste. We don't want it. We don't want it. So we take steps to try to reduce non-mechanical energy, and the amount or the percentage of chemical energy that gets converted into kinetic energy is what we refer to as the efficiency of the engine. And car engines are actually very inefficient. They generate a lot of heat that we don't want, they generate sound, they generate a lot of non mechanical energy. Energy that contributes to the kinetic energy of an object performs work. Work is a measure of the energy transfer that happens when an object is displaced by an external force. So when an engine does work, then that means that it is contributing to the kinetic energy of the car. Okay, work is when energy is transferred into something. This is one definition of work. Remember, we have a couple definitions of work, and they all they all are valid. So, if a person pushes a swing, if a boat pulls a water skier, a magnet lifts a paperclip, a static charge bends a stream of water, anything that moves something over a distance is doing work on that object. The useful energy output of a system is the work that it does. Okay, so this again is related to efficiency. The more efficient a sys- the more efficient a system is, the more work it can do, the more useful energy output it has. The formula for work is W equals F times D. Work equals force times displacement. If you haven't put it in your notes yet, this definitely goes in your notes. The work does not have a direction, but force has a direction. Force is a vector. Displacement is a vector, but work is work can be positive or negative, but it doesn't have a specific direction. So um, it can be in the direction of the force or displacement, or in the opposite direction. So, which of these photos show work being done? Well, in the first photo, we see uh, a person holding a bunch of books, and this person might get tired, may have to exert a lot of force to hold up those books. But the books are not being displaced, they're staying in one place. This is not an example of work. In everyday language, if you had to hold up a bunch of books, you might say, oh, this is a lot of work. But in physics terms, you're not doing any work. In the second image was the person pushing the wheelchair. Well, then there's force, okay, pushing forward, and there's displacement because the chair is moving. That is work. In the third picture, with um, the two guys pushing on the door from opposite directions, that I don't know why they're doing that, but they're if the door is not moving, they could physically exhaust themselves. They could push all day until they drop. They still would do no work unless the door actually moves. And in that case, only the work would be done in the direction that the door moves. And in the fourth picture, the skydiver. Well, this one's a little more interesting. Is there work being done? Well, the person's not doing work, right? The person's just falling. Uh, but is there a force exerted on the person? Yes. Okay. There is gravity being exerted on that person. Let's assume it's free fall. Okay. So there's gravity pulling the person down. And if it's not if he or she is not in free fall, then would also consider air resistance pushing back up. But there's some kind of force acting on the person, and there is displacement. Okay, because the person is moving downward. So there is work being done. What is doing the work? It's not the person doing the work. It is the earth doing work on the person, because the earth is causing that person to move over a distance, or rather the gravitational force is causing the person to move over a distance.